Morning, guys. So today we're going to be talking about divergent boundaries. So remember, last on Tuesday, our conversation centered around convergent boundaries, where two plates are colliding with one another. Um, and remember, there are three types of those convergent boundaries, depending on what types of crust are colliding. Today, we're going to talk about divergent boundaries, and I'm going to go ahead and split it up as ocean and ocean diversion or continent continent diversion. But in reality, the ultimate end game of a divergent boundary is really the same, regardless of whether it's occurring under the water or or on a continent. So divergent, of course, means to diverge or move away from one another. So we're going to start off with just discussing the ocean. And the reason that we start there is because probably the most important divergent boundary on the Earth is the mid-Atlantic ridge, which runs down the middle of the Atlantic Ocean. It is this divergent boundary that actually broke apart the majority of Pangea from being a supercontinent into the eastern and western hemispheres of the Earth. The North American continent, South American continent, all moved away from Africa and Europe because of this divergence that started to take place in the middle of the Pangean continent. Um, so again, we'll talk later on about the mechanism or the engine that's going on underneath the Earth that's causing this movement, whether it's convergent or divergent or transform. But ultimately, the point is that we're saying that these two plates are moving away from one another. And when they move away from one another, they create an open space for magma from inside the Earth to creep up into that space, harden, and create brand new crust. So the convergent boundaries are where crust gets destroyed, and it is where in the divergent boundaries where new crust is made. And so this is liquid magma coming up to the surface of the earth and hardening into new rock or new crust. Okay, and as that happens, the older crust that was here starts to move away from the center. So this split here is causing this plate to move to the left and this plate to move to the right. Okay, so again, here's another diagram here. Tectonic plates move away from each other. We have upwelling magma, and that is what is creating the new crust. Okay, so what are the effects? The effects of the divergent boundary is that new crust material is created. Earthquakes are going to happen along the plate boundary. Now, the earthquakes that occur on divergent plates are nowhere near as strong or violent as the earthquakes that occur at convergent plates. So we've been talking about the Japan earthquake of 2011. These earthquakes at convergent boundaries are or can be extremely dangerous and extremely powerful. However, most earthquakes that occur at divergent boundaries are very small in comparison and are not going to cause widespread destruction. Also, you're going to have volcanoes. Volcanoes, basically, the definition of a volcano is anywhere on Earth where magma is reaching the surface of whatever crust the magma is coming up into. So there are going to be volcanoes, especially underwater. When the magma reaches the water, it's going to cool almost immediately and become new rock. And then if that magma continues to build and build and build, then eventually the magma will grow high enough, or the new crust will grow high enough to pop up out of the water and break the ocean surface. But it's still a volcano. This is how the Hawaiian Islands were formed, and we'll talk more about that on Friday. The landforms, of course, basically is just the mid-Atlantic ridge or the mid-ocean ridges. There's more than just the mid-Atlantic ridge. That's just the most famous one and the one that the state of Texas says you need to be able to recognize. Okay, so here we have some pictures that I want to talk about a little bit. I'll go ahead and let this video kind of play. It's about a minute and a half long. It shows the birth of an island and how magma coming up from underneath the water can eventually grow high enough to pop up out of the water. But up here on the left-hand side, you see a diver here in Iceland. Um, and he is literally diving in between the North American plate and the Eurasian plate. So this is where these plates are moving away from one another. And so this water that is in between there, eventually, as the plates move to the left and to the right, will eventually fill in with more and more water, of course. This is another aerial photo of that same rift that is occurring in the middle of the country of Iceland. And you see a map here of Iceland here, where the Mid-Atlantic Ridge is running right in between that. So the ultimate end game for the country of Iceland is that this segment of Iceland is going to move to the left. This segment of Iceland is going to move to the right, and that country will no longer be one big piece. Or it could if, as the magma rises at these locations here, it fills in and creates new crust. Okay, so Iceland, probably the best example of how mid-ocean ridge or mid-Atlantic ridge or any rifting takes place can tear a country apart. Okay, so now let's talk about divergence that occurs on continents, and it's rare if you look across the entire Earth. Most divergent boundaries are located underwater. However, we do see this divergent boundary occurring on the continent of Africa, which is literally tearing Africa or going to tear Africa apart. So again, same concept going on. It's just there's no water on top here. One plate is moving to the left. One plate is moving to the right. Lava is then moving up into the space to make new crust. Again, this is the part that's called the Rift Valley. Okay, a rift is the word rift just means tear, and then a valley is just a low spot in between two high spots. So this is basically the Earth being torn apart. This is the high spot, and then this is the low spot that's in between the two high spots. Hence the name Rift Valley. Of course, the name of the one that is in Africa is called the Great African Rift Valley. Again, this is where new crust is being created. Earthquakes are going to occur along this boundary. Again, not damaging or dangerous ones, but there will be earthquakes. And then, of course, there will be some volcanoes along that rift. And again, the Rift Valley that we want to focus our attention on is the Great African Rift Valley. So you see here, the Great Rift Valley in Africa is a perfect example of how Pangea broke apart and how the Atlantic Ocean formed. So right here, this is kind of the valley that's being created, and eventually this valley will get filled in with water. And you'll see an image of Google Earth that we'll talk about during class that kind of shows you the area here. And then eventually Africa is going to be torn so far apart that water will come into this area, will become what we call a linear sea, which is a smaller body of water, and then eventually will become another ocean. Okay. All right, so here's kind of a Google Earth image of Iceland here. This is the Mid-Atlantic Ridge that started and running up in through this area and then comes down through the country of Iceland and then down into the Atlantic Ocean. Of course, the North American plate is moving towards the left. The Eurasian plate is moving to the right. And just for some perspective, this is Greenland, this is Ireland and Northern Ireland, and this is England and Scotland and Wales right here. All right, so here what I've done is I went ahead and drew a path on Google Earth to show what the underwater looks like. Okay, and so you can see here as we move left to right from here to here that this right here is what we call the ridge. Okay, the Mid-Atlantic Ridge is right here. So this is the part that is built up in the middle of the Atlantic Ocean where magma is rising up. There are a few islands that have popped up along here. One of the islands is called Surtsey that was just actually popped up out of the water in the last 50 or 60 years. So again, this is where new crust, new land is being made. And also eventually Iceland can be torn apart, this part moving to the right and this part moving to the left. Okay, so that is divergence in a nutshell. Again, remember, we will talk about the mechanism or the engine that drives divergence as we move through the rest of the week. But if you have any questions, of course, always let me know, and good luck.